Hi children, in the last class we discussed about acceleration and we do some problems related with the acceleration. Hope you understand. Then we move on to the next topic, that is today's topic, graphical representation of motion. How can we represent the motion in graph? What is a graph? Do you see? This is the graph. Yes, here this graph can be used to represent the motion. How can we represent a motion in this graph? By using this graph, we can easily identify the distance, velocity, acceleration of the objects. Okay, here we get the relation of one physical quantity with another physical quantity. So here there will be two axes, that is x-axis and y-axis. Okay. In order to represent a motion, there are two types of graph. We have to study two types of graph. The first graph is distance time graph. And there is another graph that also we have to study, that is velocity time graph. Here you will give some data and you have to draw the graph based on that data. Okay. The data may be related to distance time graph or may be related to velocity time graph. That is, if the graph is given with the distance, if the data is given of distance and time of a motion of a body, then you draw the distance time graph, and if it is given the velocity or time, you can draw velocity time graph, or distance time graph can be denoted dt graph, velocity time graph, here it is pt graph. Here distance time graph or displacement time graph, here velocity time graph or speed time graph. We can take a graph here. Okay, this is the graph. Here there are two axes, that is the first dark green lines are there and small light green lines are there. We always draw the axis along the dark green lines, that is these lines. Okay, these lines, that is I draw two axes. Then what is this axis? This is x-axis and this is y-axis. It is important to mark the axis of a graph. While drawing a graph, it is important to mark the axis, and here is the origin. Here the two axes are meted at a point and that point is the origin. Here it starts the motion. Here we are drawing a distance time graph. First we are discussing the distance time graph. Okay, here in one axis we have to take the distance and the other axis we have to take the time. Here it gives the relation between distance and time in this graph. Okay, here we take distance here. Here we take distance. Okay, distance, the unit of distance is meter. Okay, here we take the time. The unit of time is second. Here this is considered as 1 centimeter. You can see there are many square blocks here. It is taken as 1 centimeter. Here is the question, that is the data for drawing the distance time graph. That is the time is given 0, 2, 4, 8, 10, 12, and the distance is 0 for 12, 16, 20, 24. At 0 second the distance is 0. That means the object is at rest. At 2 seconds the distance covered by the object is 4 meter. At 4 seconds the 12 meter is covered by the body. At 8 seconds 16 meter is covered by the body. At 10 seconds 20 meter is covered by the body, and at 12 seconds the distance covered is 24 meter. Then here we are drawing the distance time graph, that is there are two axes here. These are the two axes. Okay, that is, this is the x axis and this is the y axis, and this is the origin, and we have to mark the time in seconds here, and distance meter, and the time second, that is 0, 2, 4, 6, 8, 10. 0. Here we can 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Here it is, we can take 0, 4, 12, 16, 20, 24. That is 2, 4, 6. That is the multiples. Here we can take the multiples of 2. That is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. It is enough. That is, it is here 24. That is, here we have to mark the distance is 0. Here the distance is 0 and the time is 0. That is, at time 0 the distance is 0. Okay, here it is. Then in the next, at 2 seconds it covers 4 meter. That is, at 2 seconds the time is 2 seconds. That is 1, 2. 2 seconds it covers 4 meter. That is 4 meter. 4 it is here. Okay, that is 4, 2. Here the point. Then at 4 seconds it is covers 12 meter. That is 4 seconds it covers not 2, 4, 6, 8, 10, 12. 12 meter. 12 meter. Okay. Then at 6 seconds it covers 16 meter. That is 2, 4, 6, 8, 10, 12, 14, 16. Okay. Then at 8 seconds. 8 seconds it is here. The time is 8 and the distance is 20. That is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, this is 20. Then at 10 seconds, it covers 24 meter. That is here 24 meter. Okay, 24. Then we can join these points, that is 0, 0 to 24, 10, 24. We can join these points. We will get the graph. That is, I am joining these points. We will get the graph. Okay, by joining these points, we will get the graph like this. Scale of this graph. How can we write the scale? Scale at the top of the graph. That is, scale is written First in x-axis we take at 1 centimeter we take 1 second. Here 1 centimeter is equal to 1 second. Okay. Here 1 centimeter is equal to 1 second. And in y-axis 1 centimeter is equal to 2 meter. In y-axis we take the distance in meters, that is 1 centimeter is equal to 2 meter. Here also the 1 centimeter is equal to 2 meter. Okay, 1 centimeter is equal to 2 meter. This is the scale. Thus we draw the graph of this data. By using this distance time graph, we get certain data from this distance time graph. That is, first of all, the distance at a particular time covered by the body can get through this graph. But also we get the speed. We can use this distance time graph to determine the speed of the object. That is, slope of this graph is the speed. The slope of the distance time graph is equal to speed. That is, we can find the slope of this graph in distance time graph. In distance time graph, slope of distance time graph. In mathematics, you have already studied to find the slope of the graph, that is y2 minus y1 by x2 minus x1. That is, here y2 and y1 and y2 are the 2 points in y-axis and x1 and x2 are the 2 points in x-axis. Okay, here x-axis, here in distance time graph we take in x-axis we take the time, that is, and in the y-axis we take the distance. Okay, we can rewrite the slope of dt graph is d2 is the distance of particular time at t2 and d1 is the distance of particular time t1, that is t2 minus t1. Okay, t1 is the time at d1 and t2 is the time at d2 distance. Hope you clear that. So slope of dt graph is equal to, the difference of distance can be written as distance, that is, and t2 minus t1, that is the difference between time, that can be written as time, that is distance by time is equal to speed. Here we can say that slope of dt graph gives the speed. We already studied distance by time is equal to speed, that is the slope of dt graph, that is distance time graph, gives the speed of the body. Here we can get the speed of the body. Then we are going to draw the distance time graph of a body at rest. What do you mean by the body at rest? That is, the body does not change its position with the passage of time. Time in seconds and distance in meters are given. Here is a data for drawing the graph, that is at 0 seconds it is 10 meter, at 1 second it is 10 meter, and at 2 seconds it covers 10 meter, and at 3 seconds also it is, the distance is 10 meter. That is, here as with the passage of time the distance does not changes. That means the position of the object does not changes. That means the object is at rest. How will be the graph of a body at rest? That is the distance time graph of a body at rest. We can draw by using this data. That is, first we draw the two axes. This is x and this is y, And here we take in y-axis we take the distance in meters, and in x-axis we always take the time in seconds. Here time 0, 1, 2, 3, 4, that is the time. Here is the origin 0, 1, 2, 3, 4, 5, 6, 7. That's enough. Here we are taking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Then at 0 second it is 10 meter. At 0 second this covers 10 meter. At 0 second this covers 10 meter. That is the point here. At 1 second also it covers 10 meter. At 2 second also it covers 10 meter. At 3 second it covers 10 meter. At 4 second it covers 10 meter. That's enough. That is, we can join these points. By joining these points we will get the graph is a straight line. This graph represents the body at rest. The distance time graph of a body at rest is like this. Okay, that is, it will always be a straight line. What is the slope here? The slope of the body. We can calculate the slope of the body from this graph. That is, this is the data. That is, here the graph, if a body at rest, the distance time graph will always be at a shape of this. Okay, this will be the graph of a body at rest. That is, what is the slope of this graph? That is, slope is equal to slope of dt graph is equal to d2 minus d1 by t2 minus t1. That is equal to, here we can take these 2 points, that is this point and this point. Okay, that is, it can be taken as t1 and this can be taken as t2. This is d1 and this is d2. This is t1 t1, then this is t2 t2. Here d2 minus d1 d2, 10 minus d1 10 divided by t2 minus t1, that is 3 minus 1. 3 minus 1, 10 minus 10, 0, and 2 minus 1, sorry, 3 minus 1, it is 2, 0 by 2, it is 0. So, slope of the distance time graph of a body at rest will be 0. The slope will be 0. Here, it means, here we know the slope of dt graph, the slope of distance time graph is equal to the speed. The slope of distance time graph gives the speed of the body. Speed, so here speed is equal to 0. Speed of the body is equal to 0. Here the body is at rest. We are going to the next part, that is the distance time graph for a body moving with a uniform speed. Okay, here the time and the distance is given. At 0 seconds it covers 0 meter. At 5 seconds it covers 20 meter. At 10 seconds it covers 40 meter. At 15 seconds it covers 60 meter. At 20 seconds it covers 80 meter, and at 25 seconds it covers 100 meter. We have to draw the graph. We have to draw the distance time graph. Here is the x-axis and here is the y-axis. Okay, and here is the origin. Here we take the distance in meters and the time in seconds. The first question, that is 0 is 0. The time is 0, 5, 10, 15, 20, 25. That is the multiples of 5. We can take it as 5, 10, 15, 20, 25, 30, 35. It's enough. Then the distance is x meter, that is 0, 20, 40, 60, 80, 100. That is, it is the multiple of 20. Here we can take it as 10 meter, 20, 30, 40, 50, 60, 70, 80, 90 and 100. Okay, in the first it is given at 0 it is 0, at 5 seconds it is 20, at 5 seconds it is 20, at 10 seconds it is 40, at 10 seconds it is 40, at 15 seconds it is 60, 15 seconds it is 60, 60. At 20 seconds it is 80, 20 seconds it is 80, 80. At 25 seconds it is 100, 100 here. Then we can join these points. By joining these points, we will get a straight line. We will get the graph as a straight line. Okay. Then the scale. We can write the scale here. That is scale. In x-axis, 1 centimeter is equal to 5 seconds. 1 centimeter is equal to 5 seconds. X-axis, 1 centimeter is equal to 5 seconds. In y-axis, 1 centimeter is equal to 10 meter. We take in y-axis, we take the distance, that is 1 centimeter is equal to 10 meter. In y-axis, 1 centimeter is equal to 10 meter. This is the scale. Okay, so the distance time graph of a body moving with uniform speed will be, distance time graph of a body will be always a straight line. What will be the slope here? Slope is equal to, slope of dt graph is equal to d2 minus d1 by t2 minus t1. We can take 2 points, that is we can take this point and we can take this point and this point. Okay, here the distance is 40 meter, 40 minus, and here the distance is 20 by t2, that is t2 is here, that is 10, 40 at 10 seconds and 20 at 5 seconds. Okay, 20, that is 20 by 10 minus 5, it is 5, that is 20 by 5, it is 4. Here we know the slope of dt graph gives the speed. The slope of dt graph gives the speed of the object. That is, from this graph we can calculate the speed, that is speed, slope of dt graph is equal to 4. So speed is equal to 4 meter per second. Here is the graph of uniform motion or uniform speed of distance time graph. It will be a straight line. These are all about distance time graph. In the next class we will discuss the velocity time graph. Then we will continue in the next class. Thank you.